All right. 5-6, we're in here with laws of logarithms. And these are going to look really confusing at first, but we'll give you some examples and actually show you that you really already know all of these laws. It's just unfortunately kind of presented in a little bit confusing of a way, but we'll break that down and get you guys rolling with them. So first thing of note is that all of the things we're about to talk about only work when, actually, let's make that a little bit clearer already, only work when they have the same base. So only work when the bases are the same. Okay, so our first one, it says that log base b of m times n is equal to log base b of m plus log base b of n. And so what's happened here is just that log base b of m has been broken into one piece, and then even though they're being multiplied together, that remember they're logarithms, and logarithms are talking about exponents, that the log of m plus the log base b of n, those will be equivalent to each other. And let me show you why you actually know that that's already true. If we have log base, let's say log base 3 of x to the third, we'll call that m, times x to the fourth, you know, okay, well, hey, if I have log base 3 of, actually, let's not do x, let's make it 3. Let's something that is really hands-on tangible. Let's do log base 3 of 3 to the third and log base 3 of 3 to the fourth. All right, so log base 3 of 3 to the third, that's going to be just 3, where log base 3 of 3 to the fourth, that's 4. And now all we did was we broke these up. If we had multiplied them together first, we would have log base 3 of 3 to the 7th, 3 to the 7th, and our answer would just be 7. But since we've broken it up, look, what do we still have? We still have 7. And that's all that's going on here, is that if we had multiplied them out, we would have added those exponents, and that's what this is talking about, that we would add right here instead of multiplying. It gives us the same thing. Next we've got division, and that's really the same exact thing. That if we have, let's say we'll go with log base 2 of, actually I don't really like using 2, let's go log base 5 of 5 to the fourth divided by 5 to the 5 squared. What is log base 5 of 5 to the fourth? Well, that's going to be 4. And what is log base 5 of 5 squared? Well, that's going to be 2. And it's being divided by, so actually it should be log base 5 of, this would be the same thing as times 5 to the negative 2, just that's that part right there. So this would be log base 5 of 5 to the negative 2 would be minus 2. And we would end up with just 2. But notice that's the same thing. If we had actually divided these first, 5 to the fourth divided by 5 squared gives us just 5 squared. And log base 5 of 5 squared is the same thing as 4 minus 2. That's all this is trying to say, that, hey, if you divide, your exponents get subtracted. Because remember, logarithms are talking about exponents. All right. Our next one is kind of even more straightforward. If I have log base b of some number equal to log base b of something else, those two somethings have to be the same. So m and n would be equal here. All right, and our last one, log base b of m to the k power is equal to k times log base b of m. And again, you know this one as well. Let's say log base 8 of 8 to the third power, that's our m, and then that let's say to the being squared. Okay. Now you would multiply these exponents here. 8 to the third, that would give you this, and that squared, that would give you log base 8 of 8 to the 6th power. And that would give you 6, because here we have 8 and 8, so we'd end up with an exponent of 6. But notice what happens here as well. According to the rule, we can take this exponent of an exponent and put it out front just as 2 times. So then we'd have 2 times log base 8 of 8 to the third. And what is log base 8 of 8 to the third? Well, the log base 8 of 8, that kind of, we're just looking at the exponent, so it's really just 3. And what's 2 times 3? Well, that's 6 again. So either way we go about it, that's all that this one is talking about. If we've got an exponent of an exponent, you can either, when possible, you can just multiply that in, or sorry, use it as an exponent and multiply your exponents, just like you did right here. But sometimes you won't be able to do that. That it won't. It'll be just either too generic, or you just won't be able to do it in that given situation. So another way to deal with it is taking that second exponent, moving it out front, and saying, "Hey, I realize that I would just be multiplying these numbers here. I'll just go ahead and multiply the value by that number instead." All right. Hope that helps, and we'll see you in the next couple videos.